In this slide, we talk about relations. Relations are nothing but subset of Cartesian products. So first we need to fix sets A and B. Say A is 1, 2, B is A, B, C, A, comma, B, comma, C. So we will find the Cartesian product of A and B, and relation is nothing but subset of Cartesian product. So it will just be an arbitrary subset. So let us write down first of all the Cartesian product. So I've taken 1 from A from set B, 1 from A, D from set B, 1 from set A, C from set B, 2 from set A from set B, and so on. Now relation is nothing but a subset. So I will just write it as S for now, and then we will later on write it as R. So I'm just picking up any subset. There is no special thing about it. I just pick up any subset I feel like, and I felt like picking 1 comma A, 1 comma B, and 2 comma A. So this is a subset of Cartesian product above, and this subset is also called relation between sets A and B. So there could be many relations. As many subsets you have, that many relations you can have. So you could have many relations between two sets depending upon what subset you want to pick up. So if I just picked up another subset, say just 2 comma C, that would be another relation between set A and B. So this relation R is between two sets A and B, and it is nothing but a subset of the Cartesian product. Now let us represent relation diagrammatically. So we have set A here and we have set B here. Yeah, set A has two elements, 1 and 2. Set B has three elements, A, B, and C. So now I will draw the relations. So first set is 1 comma A. So this is 1 comma A, the first element of the set S. Second is 1 comma B. Third is 2 comma A. That is 1 comma A, 1 comma B, 2 comma A. So the elements of set A are called the domain of the relationship or domain of the relation. And these elements A, B are called range of the relation. So these elements A, B are called, this is, I'm writing in dark blue, so focus on it closely. So this is called range of the relation. And this entire set B is called the codomain. So you can see that range is a subset of codomain. So we talk about domain of R, range of R, and codomain of R. So codomain of R is the entire set B. Okay, so now let me write down this again. This idea of domain and range is important. So domain is just the first element of the subset, yeah, because the first element belongs to set A. So this is called domain. And the second element is called the range of the relation R. So whenever you talk about domain or range, you are talking about in terms of a relation R. Another example, say you have a set A consisting of three elements 5, 6 and 8. So we want to define a relation from A to A. So Cartesian product we want to talk about is A times A. But the relation is a subset of the Cartesian product. So the relation which I have is y equals to x plus 1, where x belongs to A and y belongs to x belongs to A and y belongs to A. So as you know, relation is a subset of the Cartesian product. Now the best way to see a relation is to draw it like we have drawn the figure above. So first you fix set A and then you set A again, because this is a relation from A to A. So A has 3 elements, 5, 6 and 8. And the second set also has elements 5, 6 and 8. But you see the second set is y equals to x plus 1. Y equals to x plus 1. So y is 5 plus 1, 6. So there is a relation between 5 and 6. But 6 plus 1 is 7. It is not in the set, so we cannot draw a line. 8 plus 1 is 9. Again, there is no 9 in the second oval, so we cannot draw it. So the only set we got, or only subset we got, was 5, 6. So corresponding to y equals to x plus 1, we got only one element, 5, 6. Now we talk about more relations. So again I fixed two sets, 16, 81 and 0 as set P, and set Q as 2, minus 2, 3, minus 3 and 0. So what is the relation? Relation we will define as xy such that x is equal to 4th power of y. So we will put x as set P and y in set Q. So notice that how relations are a subset of Cartesian product, but they are a specific subset. I could have defined relation as x equals to y plus 1 also, or anything you wanted to. But here we are defining it this way. So this is set P and this is set Q, and set P has 3 elements, 16, 81 and 0, and set Q has 5 elements, 2, minus 2, 3, minus 3 and 0. So you see that 16 gets mapped to 2 elements, 2 and minus 2, because 2 raised to the power of 4 is 16 and minus 2 raised to the power of 4 is 16, and x is equal to y4. Similarly, 81 gets mapped to 3 and minus 3, because 3 raised to the power of 4 is 81, minus 3 raised to the power of 4 is 81. And 0 and 0 are mapped together, because 0 raised to the power 4 is also 0. So this is the tuple we get. So the subset of the Cartesian product which we are getting is 16 2, 16 minus 2. So this is a subset of the Cartesian product. Obviously the Cartesian product also contains element like 16, 3 or 16, minus 3, but that is not in this relation. This relation is a subset of the big Cartesian product. The Cartesian product would have 3 times 5, 15 elements, and we are writing only 5 elements in the relation. So 5 elements were 16, 2, 16, minus 2, 81, 3, 81, minus 3 and 0, 0. So what are the total number of relations from set A to set B? So as I said before, relation is nothing but a subset of the Cartesian product. So total number of subsets of a Cartesian product will give you total number of relations. So you could form any number of relations on the Cartesian product, because relation is nothing but a subset of Cartesian product. So total number of relations is total number of subsets, and so that is it. So what are the total number of subsets of the Cartesian product? So you have seen this before. Total number of subsets of a Cartesian product are 2 raised to the power of number of elements in the Cartesian product. So number of elements in set at A times B is 2 raised to the power of number of elements in A times B. So this is the total number of subsets of the Cartesian product. Since relation is nothing but the total number of subsets of the Cartesian product, so this also denotes the total number of relations. Okay, so let us give an example so as to make things clear. Say number of elements in A is 2, number of elements in B is 3. So that is comes to the first example where I have taken A as 1, 2 and B as A, B, C. So total number of subsets of this set is total number of subset of this set is also the total number of relations. So total number of subsets is also equal to total number of relations. So but the total number of subsets is 2 raised to the power of total number of elements in A times B, that is 2 raised to the power of 6, 2 times 3, which is 64.